Okay, welcome back everybody again. So we are going to go and solve a few more logarithmic and exponential equations. In fact, all of the ones on this page are exponential, meaning, well, except maybe this first one, number 9. So again, let's try to unfold what this means. It says 5 is the log we raise b to get 81. So that says b to the 5th is 81. And then we can now, if to get b, we just take the 5th root of both sides, that is, raise both sides to the 1/5 power. Okay, so b is equal to 81 to the 1/5. And then we use our calculator to find that this is approximately 2.408 on our calculator. Okay, so that's one case where we have the r unknown is actually the base. In this case, number 10, 4 to the x equals 11. Okay, let's try to write this as a logarithm. This says that x is what we raise 4 to get 11. So x is actually the log base 4 of 11. And we know by our formula this is the log of 11 divided by the log of 4. Okay. And we know that this is not 11/4, right? We have to plug in the common log of 11 on our calculator, the common log of 4 on our calculator, and divide. And when we get this is approximately 1.730. Okay, so that's what x is approximately. And you really want to be careful about how you're rounding off. Ideally, what you would do is you could, just on your calculator, just type this whole expression in all at once. What you don't want to do is you don't want to compute log 11, round to 1 decimal place, compute log 4, round to 1 decimal place, and divide it. Okay, you want as many decimal places as you can get to ensure accuracy. Okay, 5 to the x plus 3 equals 7. It's almost like this, except for x. We have x plus 3. X plus 3 is our exponent. So x plus 3 is the log base 5 of 7. Okay, so x plus 3 is the log of 7 divided by the log of 5. And we could subtract 3 from both sides. So we get log of 7 divided by the log of 5 minus 3. And this turns out to be, I think, negative 1.791. Here. Same thing here, up here. Instead of x plus 3, we have 2x plus 5. That's our exponents. 2x plus 5 is what we raise 6 to get 100. So 2x plus 5 is the log base 6 of 100. And so 2x plus 5 equals the log of 100 divided by the log of 6. Okay. Technically, for the numerator, you know the log of 100 is 2, but you can just plug this into your calculator anyway. Obviously, we need to get rid of the 5, so we'll subtract 5 from both sides and then divide by 2. So x is going to be 1/2 times log of 100 over log 6 minus 5. Okay. And then on our calculator, this turns out to be negative 1.215, approximately. Okay. Number 13. Hopefully you can see that this is kind of a dirty trick. This is it does not have a solution because 7 raised to anything cannot be negative. Okay, 7 raised to any number, it always has to be positive. So this is no solution, since 7 to 2x minus 1 can never be negative. Okay. In particular, if you had, but in particular, log base 7 of negative 10, this does not exist. And if you tried to take a common log of negative 10 in your calculator, it would give you an error message. Okay, so there's no solution here. In this case, when you have 14, you have 3 times 5 to something equals something else. This 3 we'd like to get away before we can write a logarithmic equation. So I'm going to divide both sides by 3. And we'll get 5 to the 2x plus 1 equals 120 over 3. We know that's a nice round number, is 40. Okay, and now we can rewrite this as a logarithmic equation. This says 2x plus 1 is what we raise 5 to get 40. So 2x plus 1 equals the log base 5 of 40. So 2x plus 1 equals the log of 40 divided by the log of 5. Okay, again, we're going to resist temptation to cancel the logs and write 8, correct? Okay, so we're just going to go ahead and subtract and go through the motion. So x is going to be 1/2 times log 40 over log 5 minus 1. I'm combining some steps. You obviously subtract 1 from both sides and then divide by 2, and this turns out to be approximately 0.646. Okay, so that's how you play the game. Now it's time for you to practice, practice, and the homework, and we will see you next time.